Okay, this is a limit and continuity practice test for AP Calculus BC. Okay, so this is different from AB. If you're looking for some practice for this unit, I uploaded another video for AB. Okay, so you can study using another video for AB, but this is BC. So what I'm gonna use is L'Hopital's rule. So you can use let's say 0 over 0 or infinite over infinite. Those are two form, then you can use L'Hopital's rule. Okay, so probably if you already took AB before, I believe you understand what I'm saying. So now here, let's do this one. The way you do this one, since when you plug in 0, 0 over 0, so that's the right form to use L'Hopital's rule. But since this is a fifth power, probably you're gonna take a lot of times for L'Hopital's rule. So I think it's the best way is what I'm gonna do is I'm gonna divide by x cubed top and bottom. So let's divide by x cubed. Then limit x equals to 0. Now when you divide by x cubed, 6x squared minus 8 over this one 9 minus 6x squared. Okay, I divide by x cubed on the numerator and denominator. So now you can plug it in 0. Okay, so then any term has a x in it, it will be 0 because x goes to 0, and I end up with just 8 negative 8 over 9. So answer is B. Okay, but you can use L'Hopital's rule definitely, because that is also 0 over 0 form, but you might need to take derivative multiple times. Okay, now number 2, limit x approaches negative infinite 5x minus 1. So this one simply you plug it in negative infinite into x, so answer is negative infinite. You can tell by graphing 5x minus 1 is like this kind of graph, right? So when x approaches to negative infinite means it's going this way, so your y value approaches negative infinite. Okay, so graphically you can just think about it. Now here, the function f is given by f of x ax to the fourth power plus 6 all over x to the fourth power plus b. The figure to the right shows the portion of the graph of f, and which of the following could be values of constants a and b. Okay, so this one is a rational expression here, and then they gave you already graph, so you can find out first horizontal asymptote, which is a y equals negative 3, also vertical asymptote, which is x equals negative 1. If you recall how to find the vertical asymptote, you set denominator equals 0 and solve for x, right? So x to the fourth power plus b equals 0. You set denominator equals 0, and then you need to solve for x. But since we already know x is a negative 1 is a vertical asymptote, so you can substitute into x. Negative 1 to the fourth power plus b, it will be 0. So 1 plus b is a 0, so b is negative 1. Okay, so only eliminate b. Now, let's use a horizontal asymptote right here. Then how are you going to use horizontal asymptote? The definition of horizontal asymptote, limit x offers to infinite and f of x. So ax to the fourth power plus 6 all over x to the fourth power plus b. Okay, my 6 and b looks about same, but that's a 6, and on the denominator is b. So this is a horizontal asymptote. As long as you have a same power here and here, then take the coefficient. So that's just a over 1. For horizontal asymptote, when limit x approaches to infinite, if a denominator higher power, let's say x to the fourth power at x to the fifth, denominator higher power, then it will go to 0. So y equals 0 is a horizontal asymptote. What if a numerator higher power, so x to like 6 over x squared like that, then you don't have horizontal asymptote. Okay, so you have a 3 case for horizontal asymptote. If you have a same power here, like this example, then take the coefficient. So y equals a, that's a horizontal asymptote. But if a denominator higher power, then y equals 0 is horizontal asymptote. If a numerator higher power, then there's no horizontal asymptote. Keep in mind. So this one, y equals a is horizontal asymptote, but we know that y equals negative 3 is horizontal asymptote. So a is a negative 3. That's the value. So if you look at the answer choices, then a will be answer. Okay. Now number 4. Okay. So what you can do, this is like a similar to horizontal asymptote. So what I will do, limit x approaches to negative infinite, and then if you fold it out, if you multiply it out, the highest power term is a 3x to the third power, right? Plus whatever here. But I wouldn't mind for when x approaches to infinite, you only take care of highest power, okay? And this one, when you expand it, this one fold it out, then 4x squared plus something, and then x plus minus 1. So when you fold it out again, so you're gonna get 4x cubed plus something, right? When you expand it out. But the other term is not our interest. So only highest power term. So 3 over 4, that's the value. So y equals 3 over 4. That's your final answer. Okay. Only after you expand it, only highest power term. Okay. So in this case, 3x cubed, and on the denominator 4x cubed. And then, so why is like that? When you divide by x cubed, think about it. Okay, so you have only 3 and 3 left on the numerator, and then 4 left on the denominator. And then the other term, you have a something over x. And then x equals to infinite, those terms equals to 0. Okay, so eventually you end up with 3 over 4. Now, next one, number 5. Number 5 is a free response. So you have to write down you have to explain why there must be a value of t, h of t is a -1. So how are you gonna start? So using that t value, so what I'm gonna do, let's find out h of 1 first. Okay, h of 1, so using that one here. So f of g of 1 minus 1. So f of, what is g of 1? G of 1 is right here. Okay, g of 1 is a 3. So f of 3 minus 1. Now, what is f of 3? F of 3 means here. Okay, when x equals 3, what is the y value? -3. So that's a -3 minus 1, -4. Okay, similarly, we can do h of 4. So I'm using those two values. So f of, similarly, g of 4 minus 1, minus 4. Okay, you substitute x equals 4. So f of, what is a g of 4? G of 4 is a 2 here. So this f of 2 minus 4. And then what is a f of 2? F of 2 is 8 right here. And then 8 minus 4 is a 4. Okay. Now, it said the function f and g, those are continuous. Then this complex, this function is also continuous. Okay, it's just a substitution. There's no denominator, anything. So any polynomial, as long as they are continuous, then h of x also continuous. So you can say this way. Since h of x is continuous for t is between 1 and 4, there must be h of t equals -1, I'm talking about this one. Between, so the value we found out -4 and 4, right? So -4, your h of t is between those values, right? 4. We call this one is intermediate value theorem, IVT, intermediate value theorem. So if I write full description, intermediate value theorem. Okay, by intermediate value theorem, any value between -4, you must have it. So h of t is a -1 is between -4 and 4. So by intermediate value theorem, there must be t value between 1 and 4. H of t is a -1. Okay, then that is the answer. Now let's move on to number 6. Okay, so this is what we call piecewise function. Limit x equals to 6 f of x, and then show all proper steps. For the limit, it's nothing to do with this one single value. So you have to use that rational expression for the limit, keep in mind. So first step you're gonna do is when you factor the numerator, x minus 6 and x plus 1. Oh, this one is same thing. So that's a location of hole. Okay, there's no vertical asymptote, there's a hole there. So after you cancel out, so look, limit x equals to 6, your large f of x is okay, I'm gonna copy this one again, over x minus 6, and this one cancel out. Now you plug in 6 into x, so 6 plus 1, 7. So that's the answer. Okay, is that show all proper step. Then after you factor, you cancel out, and then you plug it in. Okay, then your f of x value is a 7. It equals to 7. Now B, the value of k such that limit x equals to 6 f of x is equal to f of 6. Now when x equals 6, you have to use this. Okay, right hand side, f of 6 is a 3k plus 2. So left hand side, we just found that 7 equals 3k plus 2. Okay, now to solve that, you subtract to both sides, so 5 equals 3k. So k is 5 over 3. That's the k value. Okay, so you set equal to each other and then find it out. Now number 7, the figure shows the graph of f of x and which of the following statements true. Okay, so they give you this one. Okay, a lot of students, they got confused. There's a hole, so they believe there's a no limit exists when x equals to 1, but that's not true. For the limit, even if there's a hole, there's still limit exists. Okay, remember that. So look, the first one, when x equals to 1 from left hand side, this is a left hand side limit, right? Does it exist? Yes, that's true, because this one approach to 1, right? And then from left hand side, so it's a 3. So this is a 3. So yes. What about from positive side? It approaches to positive side here. Same value. Okay? So this is also 3. And then those two values, they are equal. If they are not equal, then you have to say it does not exist. But as you see, left hand side limit, right hand side limit, that matches. So then this is also 3. Yes, exists. So answer is D. They should say not only, but okay. 1, 2, and 3, all of them, they are true. Okay. So again, even if there's a hole, still limit exists. Okay. Now here, this is not one side limit, but if a denominator equals 0, then you have to separate it. So you have to make it left hand side limit. You have to make it right hand side limit. Okay, so x over x minus 5 and x over x minus 5. See what happened here. So think about it. X equals to 5. The first one, one side limit. This minus means it approaches from left hand side. So actually, technically, x will be 4.9999 like that, right? It close to opposite to 5 from left hand side. So it's a slightly smaller. So when you plug in 5 into this one, that's a 5 over 0, that's infinite. But since x is actually it's not exactly 5, little less than 5, right? It's a 4.999, that minus 5. So that means that that's a negative. So this is a negative infinite. Okay. What about from positive side? Now, this one operates to here, right? So x is a little over 5, so 5.000001, like example. Then, okay, that one is opposite from positive side, right hand side. So then this one will be also 5 over 0, that's infinite. But it's just denominator is slightly bigger than 5, so that's a positive. So that's a positive infinite. Now, since they are not equal, right? They are not equal. So you have to say your final answer. This one is a does not exist. It will be your final answer. Because it doesn't match. Left hand side limit, right hand side limit doesn't match. Okay? So your final answer should be does not exist. Now let's move on to number 9. Given f of x, 6x plus 1 all over square root 4x squared plus 6x plus 9. Write an equation for horizontal asymptote. Okay, horizontal asymptote, limit x opposed to positive infinite 6x plus 1 over square root of 4x squared plus 6x plus 9. Let's see. So why don't we divide by x top and bottom, right? So then what happened is a 6 plus 1 over x. And then when you divide by x, and then you bring this one inside the square root, then it will be, you divide by actually x squared, right? So then 4 plus 6 over x plus 9 over x squared. Okay? You divide by x, but you bring it into inside the square root, then you actually divide by x squared. Okay? So then after that, this one all goes to 0, right? Because x opposed to infinite. So you end up with a 6 over root 4, which is a 6 over 2, so 3. So y equals 3 is one horizontal asymptote. Now, you're not done yet because you have to check also when x approaches to negative infinite. Okay, 6x plus 1 all over. This one, a lot of people, they miss. So I want to be really careful. Plus 6x plus 9. So look at here. Now, same procedure. So I'm going to divide by x. But here's the thing. You have to really careful on the denominator. The numerator is just a 6 plus 1 over x. Not a big deal. Same thing as before. Okay? But denominator, you divide by x, right? So that denominator value itself is a negative, isn't it? Because square root cannot be, this expression cannot be negative. But you divide by negative value. So entire expression has to be negative. But here's what's going to happen. So when you bring this x inside the square root, then it will be positive, right? So in order to make negative, you have to put negative sign. Okay, that's the key. A lot of people, they miss this one. And then when you divide by x squared, 4 plus 6 over x plus 9 over x squared. Okay, run out of space. And then now, when you plug in x goes to negative infinite, doesn't matter positive infinite, negative infinite, if denominator is infinite, it goes to 0. So this all goes 0. This also goes 0. So you end up with 6 over negative root 4, 6 over negative 2, so negative 3. So another horizontal asymptote, y equals negative 3. So you have a 2 horizontal asymptote, y equals 3 and y equals negative 3. So those portion, that portion, let me explain one more time. This is kind of hard. When you divide by x both sides, but remember x is a negative value. So here, if you look at only this value here, this is a positive. Square root never be negative. Okay? Square root of whatever, that is positive. But divide by a negative value, this whole thing is a negative. But when you just bring this one inside and then without negative, that's wrong because we know that this is a negative value. So in order to keep the consequence here, you should put negative there, and then you divide by x squared, so you get this one. Okay, and then any x on the denominator, it will go 0. So denominator is a negative root 4. So 6 over negative 2 is negative 3. Okay. So your horizontal asymptote y equals 3 or y equals negative 3. Now let's move on to number 10. Okay. Let me erase a little bit here. Okay. Given the function f of x equals 1 over x plus 5 minus 1 over 5 all over x, determine x approaches to 0, what is f of x value? Okay. So let's simplify. When you plug in 0, it's a 0 over 0. So you can use L'Hopital's rule, but I don't want to use L'Hopital's rule. That one is also, it could be really complicated. So what I'm going to do, I'm going to manipulate the given function. So let's do that. Limit x approaches to 0. On the those two fraction on the numerator, if you have a common denominator, so 5 x plus 5, and then 5 minus x plus 5, and all over x. So when you simplify, you end up with negative x over 5x plus 5, and divide by x means times 1 over x. So now you cancel out, so you end up with limit x equals to 0, negative 1 over 5 x plus 5. Now you plug it in 0 into x, so negative 1 over 5 times 5 is 25. So answer is negative 1 over 25. Okay, make sure you simplify, and then you can get the answer. Now number 11, for the function f of x shown below, limit x approaches to 0, what y value approaches? A lot of people, they think is that this one x approaches to 0. They believe this is answer, but that is not. So nothing to do the one value. So this one, when x approaches to 0, so you follow this from positive side. So your y value goes to negative infinite. And also if x approaches to from negative side, so you follow this one, also negative infinite. So let me write down. So limit x approaches to 0 from positive side, your f of x, negative infinite, and limit also x approaches to 0 from negative side, that's on both of them negative infinite. So therefore, limit x approaches to 0, okay, f of x is a negative infinite. So if you say does not exist, that's wrong. So in this case, you have to say negative infinite, okay? It's not does not exist. Only time you say does not exist is if one side limit doesn't match, then you have to say limit does not exist, okay? But in this case, negative infinite. Now next one, number 12. I know when you plug it in this limit, and then x approaches to a, when you plug it in a, is a 0 over 0. Okay, so either 0 over 0 or infinite over infinite, you can use L'Hopital's rule, right? So you can take a derivative, numerator and denominator, keep going, but it will be hard, okay? So what you're gonna do is, I think the best way is you take factoring, okay? Factor denominator. So x approaches to a, x to n minus a to the n. This one, x to n minus a to the n, and x to n plus a to the n, right? So difference of scale, the factoring, right? So I see that denominator this way, x to n square minus a to the n square. If you remember, a square minus b square, for factoring formula, difference of scale we call a minus b and a plus b. So I'm using that formula. So x to n minus a to the n times x to n plus a to the n. After that, since they are same, you can cancel, and then you plug it in, x equals a. So 1 over a to the n plus a to the n. Then 1 over 2a to the n. Answer is B. Okay? So after you factor, you can get the answer. Number 13. What are the all horizontal asymptote for that? Again, horizontal asymptote limit, take the limit x approaches to infinity, or take the limit x approaches to negative infinity. You have to do both. Okay? So this one, let's do that. 6 plus 3 e to the x over 3 minus e to the x. So you can divide by e to the x. See what happened. Then limit x approaches to infinite. 6 over e to the x plus 3 over 3 over e to the x minus 1. Now, denominator goes to 0, so it goes to infinite, so that is a 0. So you end up with 3 over negative 1. Okay? So y equals to negative 3 is one of the horizontal asymptote. What about the second one? Let's do that. 6 plus 3 e to the x over 3 minus e to the x. Okay? Now, what is this? Think about it. This one goes to negative infinite. So 3e to the negative infinite, if you think about it, this one here. What is this? 3 over e to the infinite. Okay? So denominator is infinite equals 0. So this one goes to 0 already, this one goes to 0. So you end up with 6 over 3, 2. So y equals 2 is another horizontal asymptote. So answer E. Okay? So you have a 2 horizontal asymptote. So you have to do positive limit, and then you have to do negative limit. Okay? But first one, yeah, I divide by e to the x top and bottom. But second one, I show you this one equals to 0. So you don't have to divide by. Okay? So that goes to y equals 2. All right. Let's move on. Number 14. Okay. They give you piecewise function, and then what is the limit x approaches to 4? So you do one side limit x approaches to 4, negative side. Negative side, I'm going to use this. So 3x minus 2. So when you plug in 4 into x here, into 4 here, so 12 minus 2 is a 10. Now, what about right-hand side limit? Plus, so I'm using this, x squared minus 6. So 4 squared minus 6. So 16 minus 6 is a 10. Okay. Those are, they match, right? As long as they match, you can say this one is a 10. That's your final answer. Okay? So you do one side limit both of them. As long as they are matched, then that's the limit. The straight line function f is shown by the graph. Explain why there must be value x between 0 and 4 such that f of x equals pi. So your y value is pi. So let's see. What is a pi? Is approximately 3.14, we all know. So 3.14 somewhere here. Okay. So that time your x value is somewhere here. Somewhere between 2 and 3. Right? We know that this one is a continuous function, as you see on the graph. So you can say by intermediate value theorem, IVT, we already talked about it. There must be a value of t, value of x, between 0 and 4, f of x equals pi. So you can say this way. Since f of x is continuous, because it's a line, right? Continuous. Between 0 and 4. Okay. And also you can say f of, let's find out those two y values. F of 0 is 1 here, and f of 4 is basically 1, 2, 3, 4, 5 here. So that's a 5 equals a 5. So you can say there must be you can say f of x equals a pi by intermediate value theorem, because you can say using that value, right? Your y value, right? So 1, your f of x equals a pi is between 1 and 5, okay? So that y value, any y value between 1 and 5, you should have it, right? So then by IVT, intermediate value theorem, there must be one value of x between 0 and 4, and which is f of x equals pi, okay? So you can say that. Now, number 16, let's move on. Now, for the function f of x graphed below, find the when x approaches the negative infinite f of x. What y value approaches? And then you see that this one is approach to like y equals 2. You can say that later on. But this one is a negative infinite. When x approaches negative, so you follow this one actually. So it looks like keep on going. It bouncing off. So you have to say this one is a does not exist. It will be your final answer, because the function f of x bounces off, right? Bounces off between negative 2.0 and 1.0. Okay, so it never approaches a certain value. So you have to say when x approaches negative infinite, f of x does not exist. Number 17. Let's see. Based on that graph here, so that f of x is showing the graph to the right, and which are the following true. So when x approaches the 0, so this is a not one side limit, so you have to check both sides. Yeah, so this one approaches to 0, and this also approaches to 0. So yes, it exists to 0. Very good. Now, f of 0, f is a continuous. Okay. They gave you this value here. So actually, when you plug it in 0, see what happens. So this one, when you use a calculator, square root 0.0001 is a 0.01. So 0.01 minus 0.01 is a 0. So that's also true. That's the value you have there. And f of 0 is defined. I just showed here. So actually, all of them true. So limit exists, and then it's a continuous there, and then defined. So you don't have to say only 1, 2, 3. All of them, there has to be true. Number 18, f of x is a 2 over x squared, g of x is x squared minus 6. Find the when x approaches the negative infinite, f of x times g of x. Okay, so limit x approaches to negative infinite. So 2 over x squared, that's f of x times x squared minus 6. Okay, so you can rewrite this on x approaches to negative infinite. And then when you multiply that one, the numerator only, so 2x squared minus 12 over x squared. So since x approaches to infinite, when you divide by x squared top and bottom, so 2 minus 12 over x squared over 1, right? So anything on the x on the denominator will be 0 because x approaches to infinite. So 2, okay? So your final answer will be 2. Number 19, f of x be given by the function f of x. They gave you a piecewise function where a and b constants. G of x is 1 minus x squared, and it show that f of x is continuous at x equals 0 if a equals 1 and b equals 1. So continuous function means, let's talk about the continuous definition. So to be continuous, right? To be continuous x equals 0, limit x approaches 0 from negative side f of x should match with the limit x approaches 0 from positive side f of x. Then you can say f of x is continuous at x equals 0. Okay, that's a necessary condition to be continuous. So let's do that then. Limit x approaches to 0, negative side. Negative side, I'm using the first piecewise function. So g of x plus a, okay? That should be equal to limit x approaches to 0, positive side. Now using the second one, 3 minus b cosine x, okay? So when you plug it in, 0, g of 0, so you can use this one here. So g of 0 is 1 minus 0 square is 1. So I can say 1 plus a, that's going to be equal to. Now, cosine 0 is 1. So that will be 3 minus b. Okay, b times 1 is just b. So let's see. Now, they gave you when x is 1 and b is 1, does it satisfy? So let's plug it in. 1 plus 1 equals 3 minus 1. So 2 equals 2, right? Yes. Yes, it works. So that means if a equals 1 and b equals 1, f of x will be continuous because left-hand side limit, right-hand side limit, it will be equal. Okay? So answer is yes. Correct. Now number 20, for the function f of x shown to the right, find when x approaches to 3, what is your f of x value? So this one, you have to do both side limit. X approaches to 3 minus f of x. So in here, approach to 3 from negative side, that means a negative 3, right? So this is a negative 3. What about right-hand side? Approach to 3 from positive side. So then you follow this curve here. And it approaches to 0. So this one 0. Since they don't match, so you have to say this one is does not exist. Okay, limit does not exist because left hand side limit, right hand side limit doesn't match. Okay. All right, so that's it for this test. Hopefully it helps for your limit and continuity test. So you can go over it before you take a test. Okay. All right. Good luck.